Good morning, everybody. My name is Franco. Welcome to the 8th installment of Lighting Systems 20 at 10 webinar series. Today we have with us from Lumenwerx, one of our favorite regional sales managers, Sage Russel. Lumenwerx has recently launched a next-level architectural magnetic track system called Pivot, and today Sage is going to give you a brief rundown of what the Pivot system can do. Please post any questions you have in the chat, and we will address them all at the end of the presentation. If you would like to schedule a follow-up meeting with Sage, please reach out to your lighting systems representative or click the link on the 20 at 10 page on our website. Thank you for attending today, and remember, the more sessions you attend live, the more money you can earn. Take it away, Sage.
Thanks very much, Brian. Hey, everybody. I hope everyone's well out there. Broadcasting live from my little shack in Petaluma. Pivot. I'm hoping that by now you guys have at least heard a little bit of the grumblings of Pivot. I get exactly 15 minutes to dazzle you with it. I will try and drill down on some specifics so you get something for your time investment, and then we'll save some time for Q&A at the end. So save up questions, throw them in. Pivot, what is it? Magnetic track, right, as Brian very deftly introduced. I'm going to walk you through what I think are the USPs, what we've brought to this space and made unique. And coming from us, I think you can kind of guess at that. It is mostly about the modules, the light tools themselves, and the diversity of that, the heritage and the DNA. In a nutshell, Pivot magnetic track, exactly what you think, a low voltage busway with a bunch of different options for tools to put into it. Because it's us, you can expect most of the successful DNA. So we've got our traditional lens linear, we've got our glare protected MROs, a bunch of accent heads, and that's what I want to expand upon. What I'm going to do before I even talk about what makes up Pivot is jump to the most concise way that anybody can digest Pivot, and that's to show you this clever little video that marketing put together back when Pivot launched. So this is, did you fly through? Pivot exists as a recessed, suspended, and now even a surface mounted tool. Once you've started with your busway, you then go back and backfill fixtures. You've got traditional HLO, drop lens HLO. You've got a dedicated pivot wall wash, individual accent heads in 2 sizes, as well as a square. There's the box. You can see they're infinitely adjustable, flexible, rotatable. The magnetism and the induction kind of carries through to the modules themselves. There's the MRO cluster family that's been ported over. Cylinders, again, in 2 sizes and heights. And then, of course, you can suspend Pivot. And when you do, you get our best-in-class widespread indirect uplights, and then the kind of namesake flexibility, the links module. That allows for field adjustment and multi-pattern without the fuss of welded corners. We even have a vertical links, so you can actually create dimensional patterns, and then you get the whole thing in reverse. HLO, black, P-dot, box 2, dot 1.5, bunch of corners, and suspended again. There you can see cluster flush module. And that really is live examples of the types of complexities you can create in this without complicating your life. From there, I think you kind of see what we're actually doing with this and what a multifunction busway track, whatever you want to call it, looks like in the hands of Lumenwerx. And that's really what we're bringing to the table is our optics options. Unlike maybe a lot of things that fly with this flag or track in general, this is made for a lot more than just accent heads, modules, discretes, right? This is made as a linear tool. Really, it is just one more way to introduce linear lighting applications into your space. An example of patterns here, this is directly from the brochure, which is what I'll keep in the background as we march through this stuff and we talk a little bit about the features and benefits. I'm going to start off with a couple of the high-level differences. One that we've already seen lead to its tremendous success and uptake. Pivot, our magnetic track, is a line voltage tool that has no remote drivers. And that turns out to be a lot different than apparently anything called magnetic track before this. So you treat this system like linear, you drop line voltage to it through wires, and each individual pivot track section has the electronics, the integral drivers, to drop the electricity down to your 48 volts. And then all your individual light modules, be they accent head, HLO, MRO, all have current converters and managers in them. And that's where the true plug and play comes from. I have a few pivot dot heads next to me, which I know on screen aren't worth much, but I wanted to give you an idea of scale. The pivot busway itself is about the size of via 1.5. There you can see its dimension, 1.5 inches. And so the dot heads, roughly 1,000 lumens per dot head, are about that size. That kind of gives you an indication of the scale of the system. So integral drivers, that's our first real USP. The links modules that you can see here, I would say that's a second. They're fairly robust. They allow for field flexibility. And that's really important in patterning because it gives you a little bit of wiggle room to make things work. The other notable improvement, and we might be able to see this, is that besides rare earth magnets that keep these very solidly in place, there's a physical locking mechanism. And that's important, one, just for good practice, but also for seismic requirements. So these have a physical mechanism to keep them in their track. Mentioned it before, but if you get involved in suspended, you get our best-in-class widespread uplight. I think that's also maybe different than anything else in this space. And that kind of trickles down to all the optics. As I said before, really the proudest point of this is we have been able to collate and curate from our already successful architectural lighting tools and integrate them into Pivot. So again, when we start talking about clusters, you know what you're getting. When we talk about HLO or widespread uplight, you know what you're getting. So there's some of the metrics you can see: 1,000 lumens a foot, pure uplight. Efficacy is right there if you want to start already planning for lumen power density. And then, of course, when you actually get involved in the links module, you have the world at your fingertips in terms of creating patterns. One important caveat when you start building this out, part of the science and cleverness is, as a linear tool, the track sections exist in foot increments. So as you design forward with track sections in mind. We make the pivot track in 2 foot, 3, 4, 5, 6, 7, and 8 foot lengths. Those can be just butt jointed together. And in that case, just like linear, you can run pivot out as a 40-foot standalone straight with a single power drop that then through wires to down the line. Or of course, you can start building out patterns. This is high-level overview of the lighting tools. No surprise there, you've already seen them in motion, but that's the menu. You've got your HLO family with various drop lenses. You've got your pivot dot accent head families. Spoiler alert, they all have the same engine. That makes life a little easy. So they all have the same lumen output max. They have their multiple beam spreads, 15, 35, and 55. You then get into the cylinders, which are the same extrusion as the dots, so they match in size, same optic, multiple heights. You can also drop your pivot dots on rigid stems to give them a little bit of an extra drop. The bottom right on my screen, I think it works the same to be yours, is the cluster family ported over. I hope that all of you out there have some experience or exposure to the cluster family. Very robust tool, direct TIR, high output optics, low glare, and we'll revisit those later because there's so many options when you get involved in that. And then wall wash. We have actually 2 wall washes for pivot. Bottom left, you can see the pivot wall wash. Bottom right, you can see the pivot cluster wall wash, Y2. We'll revisit that too. Turns out the answer is pivot wall wash is a narrow wall wash for washing a very narrow stripe of vertical, whereas the cluster wall wash, which I would dare say is kind of world famous, has the opposite, a wide wall wash for using as few fixtures as possible to get an even vertical illuminance from side to side. There's a close-up, real close-up, of the mechanical notion on these heads. And there's kind of high-level lumen output, lengths, spectrum static. There is the pivot wall wash. And again, as mentioned, something to see mocked up when you get around to designing, because it's different, right? It is a constrained wall wash that lights a very discrete portion of the wall, very even top to bottom, but very constrained side to side. Those are application shots. There's the accent head family, the pivot dots. As mentioned, they all carry the same engine. There's more or less 3 shapes, right? You've got P.1.5, P.2, and pivot box. 3 beam angles, the usual suspects: narrow, medium flood, and wide flood, 15, 35, and 50, or there, I guess, 20, 35, and 50. Rotation adjustability. And as you guys have already seen, when you start getting involved in patterns, we can do verticals to horizontal transitions. The last few slides in this brochure, or pages I should say, are really about finish and design details, because this space is very much kind of a high spec family. We tried to throw in a bunch of standard finish colors, a bunch of internal bezel colors, enough family to give you what you need. Clusters, you can see when we start porting that over, you may be familiar enough to remember that we have 3 louver designs to shield clusters. We have the original square louvers, very kind of laser bladey looking, and then you have the hyperbolic and the conical louvers. You may or may not remember that we could do the optics 2 different ways. We have a soft beam spread family and a sharp beam spread family, refractor versus reflector, if you want to get into the nuts and bolts of it. And each of those has 3 beam spreads too. And this has all existed as long as clusters has existed. So the options are already there. And so, yeah, that's a total of 6 different beam spread options, 3 different louver options, of course, different sizes, 5 up, 10 up, the wall wash, and then you get into colors as well. The original metallics are ported over, as well as the matte black, matte white. It's robust. There's a lot you can mix and match and do. You start matching that with finish colors on the exterior as well, and you have quite a design tool. So you can back it down to very understated, integrated architectural, or you can embolden it to be a little more punchy poppy. So you can be as happy as that guy is with his pivot system. That is at a glance. I'm trying to think if there's specific details that will help you guys design with this. I think my big pitch of Pivot and what I've seen is that this product family, because of its diversity and effectiveness as an architectural tool, the HLO modules, the MRO modules, I see just as much spec and design where this is kind of the type A fixture in an open office space, because the intelligence of designing with a busway that has no fixtures whatsoever, that allows you to then backfill it with fixtures only where you need to. And I'm hoping that maybe that is a transition that the market's ready for, is to start seeing designs that are not just continuous runs of HLO linear on regular spacing in some of our open deployment areas, but something like this where you can mix and match different textures. There's a lot of that on paper. Some of them are even being deployed as we speak. So if you do run into needing images of installs, we're not too far away. And if you have any technical questions about capability, by all means, reach out. Rather than drag you through cut sheets, I'm going to keep them up here because inevitably questions beget cut sheets. And with the time we have left, I think I'd rather open it up to you guys to ask questions, because that's ultimately what bridges this to make it ultra useful. So Thomas, Brian, you guys want to fire up some questions? Do you have anything?
Yep. Yeah. Thanks, H. Let's see. Yeah, we do have some questions. Does the pivot system have or need any current limiters?
That's a really good question. So the short answer is no. And the longer answer is, much like linear, because it has dedicated integral drivers, the drivers are the current limiters. When you spec out pivot track, this is as good as any, might be better. See if we can find a better cut sheet. When you spec out pivot track, you, the lengths, and we talked about there are fixed lengths. This is a good one. So your fixed lengths here, 2, 3, 4, 5, 6, 7, and 8 foot. Each section of pivot track has a dedicated driver. That dedicated driver is roughly programmed at 12 watts per foot. So that is, in effect, the limit to the current that you can drag out of this thing. And if you need less, for example, you are designing a space and you have a 10-foot piece of pivot track and you know you only need a couple HLO modules and a couple pivot heads, you can decide that you need less electricity, and we can program the drivers to consume less. So you could program this thing to be as little as 3, 4, 5, 6 watts per linear foot if that's what you needed and you knew that was going to help your energy calc. So yeah, no current limiters. No open line track. It's all very sophisticated because of the integral drivers.
Okay, yeah, there was a question about the current limiters working for Title 24, so that answered that. Title 24 compliant, I think that answers that.
Yeah.
Another question, how do blank profiles work? How do they specify it?
Yeah, that's a good question. The blanks, and this is an important design limitation because people who are used to Squirrel or clusters or VIA, those all rely on a system where the blanks that fill in the gaps are a very simple snap-in fascia. That, unfortunately, is not quite how pivot works. So pivot blanks are really better thought of as discrete lengths that they are basically like the HLO modules, but with a finished non-illuminated face. What I mean to say is, unfortunately, as it stands, you cannot go backfill a pivot design and cover the open busway with blanks. Blanks are a tool that you can mix and match in, but you're never going to have that totally clean, smooth look. And the reason I say it is because a rendering like this would lead you to believe that you could maybe really cleverly backfill, field cut even, and put in cover plates. It doesn't quite work like that, so it's actually a really good question. It is a limitation of the sophistication because it's a live busway.
Okay, another question, can the pivot be any length?
Yeah, right, and that's a great question too, because design-wise, people love to just draw a pattern and say, hey, I want this, but pivot. And it's the sort of what I've learned in the few months this has been released is, yes, pivot exists as discrete lengths, 2 foot, 3 foot, 4, 5, 6, 7, and 8. So as you are imagining a system, you're going to have to deal in nominal lengths until you see how that shop draws out. And the other wild card is that if you get involved with a links module, the pivoting intersection, those have a dimension too, and they're roughly about 3 inches of added length. So you have to sort of take those into account, or as is often done, you can just draw a pattern roughly of nominal lengths, give it to the Lumenwerx machine, and we'll crank through it and give you a BOM and the actual dimensions of how it turns out. So yeah, fixed lengths, don't expect your exact measurements to manifest. Do check early, give us your ID, and we'll tell you what the actual dimensions will be. Great question.
Sage, is there a surface mount version?
Yeah, there is actually. And you guys actually are responsible for this. You drove it and we got there, and engineering was really reluctant, but we have it. I think I even have a modified product cut sheet for it. Yeah, so thank you, Lighting Systems. You guys push for this. We make pivot surface. Notably, what happens though, and this is the biggest caveat, is it then becomes remote driver. The big resistance was the driver is top access in pivot, more or less. So yeah, to go surface, you suddenly are back to remoting your drivers. So there is that little bit of pain. That also shrinks the profile you can see here. It becomes only 2 inches tall. It's a reminder, you didn't ask this, but it's right in front of me, so I do have to mention it. Pivot is by nature 2-channel. So you can have discrete 2 channels of control on the track component of pivot. And if you have a pendant direct-indirect pivot, you do have 2 channels on the bottom and a separate dedicated channel for your widespread uplight.
Okay, question from Nina. How does it work with enlighted controls? Lighted lighting controls.
Yeah, that's a great question. So enlighted, we're very enlighted friendly. Generally, we can OEM enlighted, but we tend not to. Just like any linear, we could probably find a way to integrate an enlighted sensor, which is also the signal receiver sender into pivot. So I would treat it like VIA. If you think you want it to be enlighted friendly, we can either find a way to integrate those enlighted components, or we can remote them if it proves too clunky. Enlighted sensors are, oftentimes they have a visual impression. They require some blank space in linear, so they would do the same in pivot. But ask, and we'll get down that road. Certainly, we're no strangers to it. And we can OEM enlighted componentry too. So if you know which tier of the enlighted system you want, IoT, networked, local, start there, figure out where you want your sensors. Then, because again, this is integral driver and standard driver, we then get down to the question of, do you want your enlighted sensor plus an enlighted control unit plus an analog driver, or do you want a digital DEXL type driver to go straight to your sensor? Short answer is yeah, we can get there.
Okay, we have time for a couple more. Kelly asks if it's J8.
It is not, disappointingly. And I don't know that it will get there. It's kind of opportunity based. There are just so many permutations of electrical configuration in the modules themselves. J8 compliance CEC Title 24 listing requires that we test each build out, and each one of these modules would have to be a different build out, and you got to test them for flicker and noise. So not on the horizon anytime soon, but keep asking. Like each time you have an inkling, let's try it and see if we can't push it a little further forward.
Okay. Sarah asks, can one section have up and down lights?
Absolutely, right. You can design by section. A suspended design like this one in front of us could have portions of direct and indirect.
Sivanti, I'm sorry if I'm not saying that correctly. Can the different modules on the same busway, two heads with different beam angles, for instance, be controlled separately?
Yeah, absolutely. Two different busways, you can connect whatever you want on those. It could be both busways, both channels are runs of PDOTs. One channel is all narrow and the other is all wide, or one channel is all white and the other is all black, or one is 80 CRI and the other is 90, or cooler warm. But yeah, absolutely. Mix and match to your heart's content.
Okay, two more real quick ones from Amanda. Can the drivers be accessed from the bottom? I think you may have answered that.
So in the case of recessed, obviously the drivers are accessible. It requires a little bit of faffery, a little bit of tools. In the suspended version, it's actually easier to get to the driver from the top. But in all cases, they're accessible, right? NEC requires that, which is why, again, in the surface mount, you are relegated to recessed, or remote drivers, rather.
Okay, one more question from Elaine. Can the surface track be side mounted, and what are the adjustability angles and rotation on the pivot heads?
Can the surface mount be like maybe wall mounted, side mounted? Let's start with the easier. The rotatability and adjustability of the PDOTs is nearly infinite. Here's a PDOT, 90 degrees, maybe even more, 92.5 degrees in any direction. And then the pivot is whatever, rotation, spin, revolution is whatever. So yeah, infinitely adjustable and pivotable and spinnable and aimable. Now, surface side mount, I can't quite picture it, but we can take it offline. We'll get to an answer.
Okay, I think that's, yeah, and Elaine just clarified wall mount.
Wall mount pivot, yeah. We haven't explored it. Possible. I mean, anything's possible in Lumenwerx land.
Okay, kind of running out of time here. So on behalf of Lighting Systems and Lumenwerx, I want to thank you all for attending today. I also want to remind everyone that next month we will be presenting the tracker, Guion, and wave fixtures from Intralighting. Remember, if you have any additional questions or would like to follow up with Sage, please reach out to your Lighting Systems representative or click the link on the 20 at 10 page on our website. Thanks for joining, and everybody have a great day. Thanks, Sage.
Thanks, everybody. Yeah, absolutely. Thanks for tuning in. Thanks for your time.